Hi, I'm GUO CHENG GUANG, Primary 6 from YUMIN Primary School. For this time, methods of limit calculations. We'll have some more examples showing us how can we use this differentiation and integration both together. And in the middle, we use the geometric progression. So up here, we will have another example. But this example is more different. In this example, it actually says sigma n from -1 to infinity, then n times n plus 1 over 2 to the power of n plus 3. This thing, what's so special? But did you realize now the n and the n plus 1 is now in the numerator instead of the denominator? Okay, now that thing changed. So, how can we simplify this question? Now you have to take note. -1 sub inside. This part is a 0. So, when -1 is still a 0. But how about 0 sub inside? Then n would become a 0. So that means it's actually starting from 1. Like this. So it's actually starting from 1. Now here, I'll show you 2 different methods of solving this. Upcoming. First method. So first method is our usual method. Okay, still we need to let this function so that this coefficient in the numerator, afterwards, we can just cancel them or simplify or just use them. So in this part, x to the power of. So in order to remove these parts in front, we need n minus 1. So what happens here? First differentiate or first integrate. So just by looking at this, you can realize, well, we need to first integrate so that this n will be taken up. Okay? Alright. So when we first integrate inside here, well, is it okay for it to be from 0? Well, of course, because even if you start from other numbers, for example, 1, 2, this part, dx, d over dx, it does the job. All those constants differentiate 0. Don't need to care about them. So it becomes like this. Now what happens here? So this part, n will be taken up, x to the power of n over 2 to the power of n plus 3. Like this. But the problem here is n plus 1. We still have that coefficient. We will need to remove it. So another time of integration and differentiation here. So that would mean we'll need differentiate it 2 times. Like this. Then how about here? So n plus 1 taken up. Now it becomes like this. But at this part, how should we deal with them? For example, this denominator. How should we deal with this? So let's try. Now here you have x to the power of n plus 1. And here it just goes increasing by 2. Wait, isn't it simple? Since this is still the geometric progression, Why? Because let's try this out. 1. So I have x squared over 2 to the power of 4. Okay, let's just write it this form first. When you sub 2 inside, you get cube and to the power of 5. When you sub 3 inside, 4 and 6. So did you realize this is just times x over 2 times x over 2? That's it. We have found a pattern. Simple. So that means for this part, what we'll need is, so the first term, x squared over 2 to the power of 4, you have to over 1 minus their ratio. Okay, so this part I don't think we need it anymore. Now it's time for this. How can we make this simple? Maybe you could times 2 to the power of 4 on both sides. Let's try that. So here's 2 to the power of 4. Then they will have a 2 to the power of 3. So that's an 8. And this part in front here is actually 16. Like this. Simple. So now you differentiate. But this time, differentiation is different. You have to be aware of this. You would have to use chain rule or product rule, but you have two choices, product rule or chain rule. Okay, so I'll just explain about that here right now. But what if I want to make it even more simpler? Just take this 8 out. Because it is a constant, so you can just leave it alone here. So you can make it become like this. Now, which method to use? It's up to you. So right now here, I'm going to use our product rule. So you see the product rule. First, I differentiate once. So let me differentiate this once. So here you have 2x. But here, let me just write it in power form. I want to don't make myself confused. Okay, so this is first. Then the second. So plus this, but okay, plus. So here's x squared. Then down here, 2 minus x. 2 minus x to the power of negative 2. But then you have a negative. But inside here, because it's a negative x, so you have another negative. Then a negative, negative, positive. So it's still a positive. Okay? Then after that, we'll differentiate this again. So maybe I'll just write this below. So what happens? First term, we use the product rule again. So you get a 2. Like this. Then that's for the part at the back. Okay, so let me just write this 2 properly. Okay. So it's this part at the back. So I have to negative, negative, still a positive. But this part, we have to be careful what's happening. Firstly, x squared. So you have 2x. Then for the second part here is product rule for this part. So it's this power, you need to take it down. But still a negative, negative, positive. But beware, here you have a negative 2. So then you still have a 2 over here. Then at this part is a negative 3. And then after that, we have something like this. So 2, well, all of them can be simplified. Okay. But at last, this general case, it includes our special case. So we have to find still for our special case. Okay, so beware, this is a 1/4. So this part is a 1. Okay, still a 1. So these parts becomes 1. Then after that, this is still 1/4. So this is another 1/4. 4 of the 1/4. Basically, it's just 1. So this is the first method that I am using. So the first method is something like this. It's just x to the power of n minus 1. Now I'm going to use another method. A bit different. Okay, so take a quick look at this method. Okay, so I'll move on to the second method. So, second method. I'm going to show you a method a bit different, but the denominator, you might find it quite simple. Okay, so still we have to let. So this function, we still have to remove these coefficients. So what happens? This part, we need to write it down first. Every single time we have to do that. X to the power of n minus 1. Okay, then you might ask me, how about, why did you say that we're using a different method? Okay, let me show you. In this method, going to add a 2. So what happens? Basically, it just simplifies with this denominator. And then sometimes, like in the first method, you might find, well, I have that 2 there. Can I make it simpler? So let's try this method, whether it will become simpler. So still the same thing. We have to remove both of these coefficients first before we can use our geometric progression. Okay? So, integrate first, because this coefficient is together with this x. It is both times together. So, just take note of this. Times together, you use integration first. Divide, then you use differentiation. But sometimes, like for example, if your power, you use a 1 over something, then that will be the other way. But to make things simple, I'm just going to use this simple. So, these two simplify until this denominator is just left with 2 to the power of 4. That is 16. Simple. But this coefficient in front is still there. So, differentiate 2 times. denominator, same. Am I right? Simple. So right at this part, things start to change. We'll have to use our geometric progression. First term, what is it? X squared over 16. But 1 over 16, isn't it confusing our process? There will be 16, and then somewhere in the denominator, it happens again. And, well, that makes things complicated. And we don't like these very complicated things. We want to make it simple. Simple as possible. So we take this 1 over 16 outside. Then left inside is just this thing? Are you serious? So you also differentiate 2 times. Then first term, x squared, 1 minus x. Just this simple. But not like just now. I am not going to use product rule. I am not going to use quotient rule. I am going to use another method. So hang on first. I'm not differentiating you yet. So it's so simple. Now here is x squared. But did you realize x squared, what if we factorize? What if we partial fractions? But down here you have a negative. Okay, so let me just write it here. Down here you have a negative. So you need another negative. So that it becomes like this. Is it simple? Here, this part, partial fractions, simplify, then just simple differentiation. Like this, differentiate once, wait. Here just the simplification and partial fractions part. I haven't started differentiating this yet. First time differentiation, 1, 0. We'll see about that. At this part, to the power of negative 1. But this is no negative. It is not a negative. So we'll give it a negative. So what happens here? X minus 1, negative 2. Is it right? After that, differentiate again. Negative 1 over 16. And then what's here? 1, no more. Negative, no more. But what happens? You get this stuff. Simplify. But don't panic at this level. Don't panic. Even though here's a negative, but later you'll see a bit of magic. So I can show you the magic right now here. I can also show you the magic later. Okay, so I'll show it later. So let's start in our special case. Okay, but wait. Not every time is 1. In this case, you start in 1. It totally changed it. We have to simplify this too. So basically, we need a half. Now this is 1. We need a half. So when we need this half, starting inside, negative of 2 power negative 3. Now first, this might seem confusing to you, but let me tell you what it is actually. 1 over this thing. So when you have 3 of this negative and another negative, well, that will just give you a positive. But what's so special here? Denominator of denominator. What to do? Reciprocal. Simple. 1. So this method is just so simple. So you have to be aware of methods that you are using. Different methods will give you different processes. Some processes very, very simple. Other processes, well, you might think it's okay. And there are even worse processes. It makes you think a lot. Very, very complicated when you can just use a method so simple. Okay, so in this lesson, I hope that you are clear. So beware, there's 2 methods, but there's actually more. These 2 you can still change this part. You can change it to product rule, quotient rule, factorize, partial fraction. Well, there's a ton of methods here. So for all of these, I hope you are clear. We have used quite a number of methods that we have learned. So for this part, I think I can end this over here. Now this question is actually quite interesting. You can find out so many new methods. You can simplify if you want. There's a lot of things to explore. It's a big wide world out there. So this lesson, I'll just end it here. So if you like our videos, don't forget to subscribe to our channel. We'll see you in the next lesson, and thank you for your watching.